All right, so today let's take a look at how some noise sources get into our sound systems through our cabling. Now, there are four common noise source types that we run into. One is electrostatic, when you wipe your feet on the carpet and you touch someone and they get that spark. Another is ground loops, where the grounding differential between pieces of gear allows electrical voltage, AC voltage, to travel through your wires and induce sound into your system. The third one is EMI, electromagnetic interference, and that happens when you have a coil of wire or energy traveling through a wire. It can create what it sounds like, an electromagnet, like when you wind a piece of wire around a nail and hook it up to a DC battery and it turns into a magnet. Well, that magnetism and those changes in magnetism can be audible and destructive to our sound. And finally, we have RFI, radio frequency interference. And that's where high frequencies from radio stations or just high-speed switching from dimmers or electronic equipment, computing equipment, induces some sort of noise. It can be a radio station, but it can also just be clicks and pops and other sounds. Now, there are other types of noise, but those are the four most common that we run into in our cabling systems. And so today I'm going to look at EMI and RFI, those two types. And to do that, what I've got is a transformer. I did this in another video where I took the electromagnetic field, electromagnetic radiation, and we could hear that in the wiring, and you should check that video out for more in depth there. And today I've got something new where I created an RF noise source. And to do that, I use this function generator, and I have it sweeping very quickly between approximately 30 and 40 megahertz. And it's just making a sound there. Just this tone is going whoop, 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 whoop. And that is hooked up to this wire, just a single copper wire with insulation on it. And what I'll do is, I've got a mic stand up here, I can hook it up there, and we'll be able to hold various cables up to this RF noise source and hear what they sound like and see what the impact is. So it turns out that electromagnetic interference, EMI, and radio frequency interference, RFI, are very different. And the tools or the methods that we use to prevent them from getting into cabling are quite different. And so there's kind of a balancing act in order to get these things optimized. So the optimum cable for radio frequency issues is a bit different than the optimum cable for electromagnetic issues. So I've got this mixing board, it's a Behringer wing, I've got the gain turned up all the way, I've got the trim turned up all the way, and the faders are up quite loud as well. So we're really looking at a lot of gain here to help us hear these problems. All right, let's start with the mic cable. And the first thing I'm going to do is unmute the console with nothing plugged in, and we can listen to the open mic preamp noise. And we hear a load of hiss. We'll mute that. The next thing I'm going to do is plug in the mic cable without a termination on the end. The termination plug that I have here has a 150 ohm resistor between pin 2 and 3. And a secondary connection between the shell ground and pin 1 so that we don't have handling noise on there. And we'll turn that on. And we'll put the termination plug on. And there we have it. So first we'll check with the electromagnetic. And next we'll check with the RF, and I'll plug this antenna in. "90 degrees, parallel." It's everywhere. Let's go ahead and mute that. And let's go ahead and look at what type of cable this is. This is a Livewire Essential microphone cable. Let's take a look at its shielding, because the shielding will make a difference here. Pull this back, and this is a serve shield. So it's a spiral wrap around the center conductors. All right, so let's go ahead and check out another cable here. This cable Let's open it up and take a look before we start. See what kind of shielding it's got. And this is a braid. I can see that it's a woven braid. This cable is labeled Cable Factory LLMT-224 Touring Mic Cable. We'll go ahead and put the termination plug on and fire this up. And there's our electromagnetic test. Really kind of excited. I'll move that over there. And let's fire up the RF. Much quieter than the other one. It's there, but not anywhere near the level of the other one. Very cool. Okay, next cable. This cable is a CBI Ultimate 20 gauge Molt braided shield. All right, so we don't need to open it up. We know it's a braid, and we'll plug this in, put on our terminating plug, unplug our RF source, and we'll do the pretty good. All right, and we'll RF it. Pretty loud, okay. Definitely more noise than that last one. Here's another kind of fun little thing. Here's a magnet. This is from a broken speaker. Watch what happens if I rub a magnet along the cable. Electromagnetic radiation. Here's basically a DC source, and when I move it along, we're creating noise. We can actually hear the jacket there too. Awesome. All right. Next cable, we'll do an inexpensive imported cable that's got molded ends on it, and it looks like a little rubber band to mark this thing. Doesn't seem like that's going to last very long. And this would be one of those really cheap cables you buy on Amazon or something to save money. Okay, it's called the Professional Low Noise Audio Cable. We'll see if it lives up to its name. Let's go ahead and fire it up. Oof, okay, quite noisy. And magnet noise. And let's fire up the RF. Definitely not our friend with RF. All right, for our next cable, let's check out something really interesting. I've got a Mogami Neglex quad mic cable. A lot of people call these quad star. It's where you have 4 conductors instead of just 2 that are twisted together, and they're opposing. So you got 2 pluses and 2 minuses, and it's supposed to really help with induced noise. We can take a look at that on the inside here. I'll pull this apart. And you can see that there's 2 blue wires and 2 white wires, as well as the ground, and it's got a serve shield. It's not a braid. Cool, so let's see. This should be impressive, right? This is a cable specifically designed to deal with noise. All right, let's go ahead and unmute this. All right, we'll check the electromagnetic. Check that out. That's a little bit there, but I mean, this is really good. I mean, that's as good as it gets. Try it with the magnet. It's some there. We can hear some of the cable jacket, but again, really good with the electromagnetic. Let's go ahead and fire up the RF. Ho! That's actually the worst that we've run into. The best with the electromagnetic and the most susceptible to the RF. Really interesting. So after testing the Mogami cable, I went on to test a Whirlwind 6-channel snake and a Sound Tools 4-channel analog over Cat5e snake as well. And I'll show those tests in a bit. But this quad cable having so much RF interference really bothered me. So I went and looked up the Mogami website, and I see that it specifically says to use this quad cable to help reduce RFI interference or RF interference. That's counterintuitive, first of all, because the quad conductor is better for electromagnetic and shouldn't really benefit for RF. So the next thing I did was order a Canary 4E6S cable and looked at their website as well. They claim that it has improved performance for EMI, or electromagnetic interference, which makes more sense. So now we have two conflicting websites, two conflicting products. One claims excellent RF rejection, the other claims excellent EMI rejection. So let's go ahead and test those out and see how they perform compared to a regular mic cable. Is this quad stuff better? So to establish a reference, I'm going to use this 2-conductor mic cable. It's about a 6mm. They're all about the same diameter, just as a good comparison. And I had to wait for this Canary cable to come in. I want to make sure the test setup is exactly the same to compare these three. Also, what I'm going to do is I'm going to expand the bandwidth of the generator. I was testing at 30 to 40 megahertz. Let's go ahead and go to a lower and higher frequency. And I'm going to go from 10 megahertz to 60 megahertz. And we'll do it a slower time frame, and we'll go to a half a second. Give it some more time to do that extra sweep. So let's go ahead and fire up this cable here. Electromagnetic. I'll try and do it the same for all of them. And RF. And what I'll do for that is I'll grab the end of the cable, hold the connector on, okay, there's our mic cable. And also, this is not all the RF that could possibly happen. This is only going up to 60 megahertz. There are frequencies that go much higher. So this is a limited range, but it should give us a good idea. Now this is the Mogami. Wow. So the electromagnetic is really awesome. And we'll go to the RF. Already it's just really, really noisy. I think that's going to clip the meter for my... That's too loud. It's so loud, it's too loud for the settings that I've got. So, all right, now let's check the Canary. Is there a difference between quad Mogami and quad Canary? Let's find out. Well, that's interesting. The Canary is more noisy with the electromagnetic. And in their website, they claim electromagnetic is their forte. Not as noisy as the mic cable, but more noisy than the Mogami. Let's try the RF. All right, we'll look at this on the software, and I'll put the dB level up. All right, there you have it. There's the comparison of the quads to a mic cable. Super interesting. Cool. All right, so back to yesterday when I was doing the test on the snakes. All right, for the last two cables, let's go ahead and do snakes. So here's a 6-channel whirlwind snake. Put the terminator in and plug in channel 1. Let's fire it up. Now, these are antennas. All these extra ends that aren't plugged in are sitting there like antennas. All right, so here we go. Let's go ahead and check that now. Not great with the EMF, but these are 100% foil shield. It's got a drain wire and foil covering the entire thing. That's the best protection, so it should be really good with the RF. Let's check that. We can hear the electromagnetic, and that's to be expected. The shield does not save you from electromagnetic. Magnets go right through the shields, and electromagnetic fields do as well. The 100% shield protects you from RF induced on the cable. The problem with 100% shields like foil is they tend to be stiffer and they're not really good for things that are moving around a lot, like mic cables. There you need something more flexible, like a braided shield or a double serve. A serve shield this way and another serve shield going the other way, and they give you a very high degree of shielding, but they maintain their flexibility, and they still don't protect you against electromagnetic. What protects you against electromagnetic is the twists. An audio cable has a slow twist rate, whereas cat cable has a much faster, and let's check that out. Here's a Sound Tools cattails. I'll plug in one just to start with, and then we'll see how that is, and then add the others. All right, electromagnetic, let's check it out. Now let's go ahead and plug in the other tails. A little quieter. Let's check it for RF. And we can hear some RF there. Let's go ahead and untangle this a little bit. Now this has a single braid shield over all 4 pairs. Using a cat cable like Super Cat 7 or XM that has foil shields would give you that RF rejection, but you would make a sacrifice in the electromagnetic field rejection, similar to what this does. All right, that was kind of fun looking at the electromagnetic and radio frequency interference impacts on various types of cables. And generally what we saw was that electromagnetic interference is mitigated by the quality of twists. The quads did good with it, and tightly twisted cables do good with it. It has to do with keeping those 2 conductors about the same distance from the noise source as best as can be done. And the RF interference is mitigated mainly by the quality of the shield. 100% shielding. The serve shields don't do a great job. Tightly woven braids do a good job, and the foils do a great job. So there's kind of 2 different types of interference and 2 different ways to mitigate them. Now, I didn't test with broadband RF. I used 10 to 60 megahertz, and higher frequencies will impact cables differently, and different types of electromagnetic fields, as well as things like ground loops and electrostatic discharge. But this gave us an idea that there are vast differences in the way that these cables deal with noise. 2 cables that look the same may perform completely differently, and cables that claim to perform well may not do so. All right, hope you found that interesting, and I'll do ground loops and more on cables soon.